Spencer Michaels over here in sunny California, ACT LA office. I'm joined today with my coworker, Will Murphy.
Hey everybody!
Today is day 2 of Fixture Profile Bonanza building. Today we're going to talk about the more specific ways to build the advanced fixture profile attributes. So talking about Gobo wheel 1 or 2 or 3, talking about color wheel 1, 2, 3, talking about Prism, talking about shutter. So these are attributes that require some more attention to the sub-attribute level and the function set level. So yesterday we went through just putting in the attributes, applying the course number, the default values, the highlight values, and snap, a little bit of module manager. But today we're going to be going into the wheel manager and specifying how to build these profiles so that they visualize in 3D well and they work with your fixture well. So let's start with color RGB 1, 2, and 3. Now, I'm taking a Mythos fixture profile, and I kind of cleaned out the inside, and we're going to rebuild it. I'm going to rebuild it with you. Yesterday, I mentioned that you need to be looking at your DMX channel chart when you're building fixture profiles. Here's the Mythos DMX channel chart. The way Clay Packy builds their charts is by first laying out the attributes and their channel. So just to clarify, that channel number is where you put in your course number, right? And then if you scroll down, you'll have a better idea as to what DMX controls what part of that attribute. So we'll start off with the cyan, magenta, and yellow color wheel. Okay, so in MA, we want to use the color RGB 1, 2, and 3 attributes. Now when you assign this and you look in the color section, color preset type section, you'll see R/C invert. Okay, what that means is you're going to use this attribute for red and or cyan with the invert assigned to the cyan. So it's the difference between additive color mixing and subtractive color mixing. Red, green, and blue LEDs, that's additive color mixing. Cyan, magenta, yellow, that is subtractive color mixing. And they kind of work differently on how they output to the attribute. So first off, assign your 3 attributes, cool, do the course numbers, and then the default and highlight. If we look at the channel chart, we see that 0 to 250 is our DMX value, and it's a linear cyan movement. So we can assume 0 is closed and 100 is open in essence, because when you put in cyan, magenta, and yellow all at the same time, it is not allowing any light through, basically. It's basically a black. If you have them at 0, which means they are not in front of the beam, it means they're open. So I have these set to 100 because if I look at my sub-attribute level, I've flip-flopped the from and to columns and the from and to physical columns. Now what that does is, remember from yesterday, from and to is the natural range of your encoders. So when my encoder is at 100%, my DMX value is at 0, which means my cyan wheel is open. Okay, and it makes a little bit more sense when you roll the encoder to 0, basically. When you roll it up, it's actually putting in the cyan. It's a little weird, I know. It's hard to explain and show you just from the software, but trust me, this is what you want to do when building cyan, magenta, and yellow attributes in a fixture profile. If it was RGB, you would do the same as ever, from 0 to 100, from DMX 0 to DMX 255, 0, and 1. Okay. If you go in one step deeper, you'll have your function sets. Your max is 100, so all cyan or no cyan. This always confuses me, Will. I think maybe it's easier to just use the invert column and just use it regularly. It kind of depends on trying with your fixture and seeing what works best.
Yeah, we no longer suggest using that invert function on the attribute, the standard library now, because we switched to a additive mixing system. we want you to reverse the sub-attribute, just like you showed them, because the opposite of RGB is CMY, and this changing the from and to and from physical and to physical makes it possible to do fixture swapping without problems. Whereas usually, or do cloning, for example. Whereas if you use just the normal invert the attribute, sometimes the fixture swapping and the cloning doesn't necessarily work the way you want. It's also important to follow the standard approach of the internal library. So the standard approach of the internal library for all CMY fixtures will have these values inverted just like that.
Right. Cool. So again, you want to rinse and repeat for magenta and yellow. Biggest thing to keep in mind is you're wanting to use color RGB 123 and inverting that sub-attribute level. Cool. Let's move on to Gobo Wheel 1. So this takes a few steps to set up. First off, I like to, of course, assign the attribute, then go and edit that attribute, and we have our sub-attribute here. This is a Gobo 1 select. Okay. This natural range is going to change, and the DMX range is going to change according to my DMX sheet. So if I scroll on down to Gobo 1, there we are. This is the static Gobo wheel of the Mythos. So you'll see the static change. This is me selecting them, and then I get a new feature here: continuous Gobo wheel rotation in one direction and then the other, and then Gobo wheel shake. So essentially, these are three different ways to visualize the Gobo. Therefore, we need three different sub-attributes in Gobo. I'm going to leave Gobo 1 select for selecting them. I'm going to change this Gobo 1 to spin because that's a spinning feature. And I'll leave Gobo 1 select for the shake, but I can rename this name as shake, and that's what pops up in your pop-up calculator in the encoder bar. Okay, so now I've added these, and you'll see I have a from and to 100 for all of them. I need to change that. First off, I want to start with the DMX from and to. So if I look, I have a DMX value of 0 to 69 for my static Gobo change. So then I just go in here, change this to 69, and I know that the next value for spin is going to be 70. Take a look at my DMX sheet. Well, look, it skips a few DMX. I'll do 72 through 159. Okay, so this goes to 72. This goes to 159. Okay, 159. And then finally, our Gobo shake is 160 through 255. So again, 160, 255 is already in there. Make sure that it's there. Cool. So now I need to assign my natural ranges. So now that I have the DMX values in here, I get to use the pop-up calculator in the console itself. So I'm just going to right-click or click in on the screen encoder for the 2 column of the first one. I'm going to do some math. 69 is the DMX value divided by total DMX value of 255 times 100. Boom, there's my percentage. Now I get to rinse and repeat. For the rest of these. And now you see why it takes us a little bit of time to build fixture profiles, because it's a lot of this repetitive tapping of buttons.
I want to ask you something. It's important to remember. You've left a gap in the channel. You know, the natural range 27.06 and 28.24. You know, if your encoder dials into 28, do you know what happens to the DMX output?
It's going to drop to 0?
Yeah. So keep that in mind. If you guys leave gaps in these ranges as you're spinning through the encoder, between 27.06 and 28.24, there's going to be a gap, and the system doesn't know what it's supposed to calculate, so it drops the DMX to 0. So usually I would say it's not a good idea to leave gaps here. I'd probably just change the 2 value 69, I'd probably just change it to 71.
Okay.
And just fill it in, because I think what you're going to see next is we're going to define the function sets, right? So we're going to say specifically the Gobo is 69, but we want to avoid these gaps in here.
Yeah, but you see when I do that calculation, it does put in that gap. It's always going to be off by a 0.5 value. So I don't know if maybe putting in the actual.
Yeah, I have some
7.85.
I've gone in individually and made sure there's no gaps in these sub-attribute from and to ranges, just so to avoid that drop to 0.
Cool. Okay, so we have our sub-attributes done. Now we want to back up, and now we get to go into the wheel manager. So in here is where you're going to apply any attribute that needs to visualize color wheel, Gobo wheel, animation wheel, Prism. These are just a few examples. So we're going to add a Gobo 1. So let's just delete this real quick and add it again. So you can see that you need to go through that list of sub-attributes, find Gobo 1, and find select. So now we've added the sub-attribute Gobo 1 wheel. Now if we edit this wheel, we have a blank space again. We get to add the number of slots as we have Gobos, +1 for the open. So if I go back to my DMX channel chart, you'll see I have the first position is open, and then I have 18 Gobos. So that means I need to have a total of 19 lines. Cool. So we got the number over here, we got the media name. This is just for your organization. I like to start the top one as open, and then I can select all of these, scrolling on down, and then say Gobo 1.1. And the console is smart enough to enumerate the last value. Okay, and now how do I assign an image to this slot? So you have color and media file name. Media file name is going to be for Gobos. Color is going to be for the color wheel. So we'll leave that alone for this one. But we can click in the gray field and then right click or click in on your screen encoder. And then you get this open file pop-up to look through your internal library Gobo collection. This is the absolute best part of creating fixture profiles. And I say that with sarcasm. I hate looking through the Carillon library for Gobos, but sometimes it's a necessary evil. You can put in your own user Gobos and have custom Gobos, but the thing is with this, these Gobo images then need to be imported into your console or into your on PC and imported to any other console that's going to be using this fixture profile. Because this is just a file path. This is just telling the console to look in this directory for this slot for this Gobo. On another console, this Gobo doesn't technically exist, therefore it's going to be blank. So that's why it's best, in my opinion, to look through the Carillon library or these other Gobo libraries for your particular image. They are split up by manufacturer. So I'm just going to look in the clay packy, and then as we select one and scroll down, we get to see a little preview of what that Gobo is. Now, I'm not going to sit here and do this for every Gobo, but I will tell you a couple things. You have these iris Gobos. Those can be found in the Carillon library. Scroll on down. In Gobos, scroll on down to generic. And the first few of these will be your iris Gobos. That's always a good go-to. So if I look back here, we have a pin spot. I'll use this one. And so on and so forth. For the next images, we have this kind of crosshatch thing. That's when you would probably look, what is that, Gobo number 7? I would look in clay packy again and scroll through here. If you don't find the Gobo, find a Gobo that's close to it. I mean, this is just for the user themselves to be like, oh yeah, it's this Gobo. So you have a whole lot of options to choose from. I'm just going to go ahead and call it this Gobo, even though it's not quite that one. But you get the idea. You have all these Gobos that you fill out. And now we get to go back into the Gobo 1 attribute. And we need to look at this wheel column here. This wheel column connects this sub-attribute to the wheel manager sub-attribute that we created over here. Right, so if I go into the Gobo wheel, I right click and I choose my Gobo 1 wheel. Great. Finally, I get to go ahead and edit that sub-attribute, and now I'm in the function set layer. I'm going to again add 19 lines, and now I'm going to create shortcuts for every Gobo that I have in my wheel. I'm going to label it the same, Gobo 1.1 through 118. Then you get to go through the fun of assigning the DMX values. So 4 through 69, I could try this. Select all these guys, scroll down, and do 4 through 69. Scroll to the left, type it in again, 4 through 69, because it's the full value. And then I need to cross-reference this value. So Gobo 1.1 is DMX value 4, confirmed. 2 is 8, confirmed. 3 is 12, confirmed, so on and so forth. Finally, you have your slot number. So this pertains to the wheel manager. The first slot is 1, and then we'll also have to type in the through. So 1 through however many slots we have. And there you go, 1 through 19. Lastly, you have the from physical and to physical. You want to leave the first one at 0 always, especially for color wheel. But for Gobo wheel in particular, you want everybody to be at 0. This is because it's telling the console and 3D to snap to the full Gobo. If you do -0.5 through 0.5, it's telling 3D to scroll through those Gobos. So that's particularly useful for color wheel, because the color wheel sometimes scrolls through the colors depending on the fixture profile. With Gobo, we want it to snap to it, therefore we do from to 0.
Yeah, keep in mind that those are physical columns, right? Which means they only apply to 3D and the little thumbnail previews that you see on the desk. They have no correlation to the actual DMX output.
Right.
We covered that snap setting in yesterday's webinar. And while we're here, there's a question about inputting your own pictures into the library. Spencer touched on that, but maybe it wasn't quite clear enough. Just want to explain that again, Spencer.
Sure.
If you're trying to do your own images, what's the conundrum?
Right, so let's say I have a fixture profile that has custom Gobos. I don't want to search through the library, so I'm going to find those images on the internet, and I'm going to import them into my console. Because I import them into this console, they only really exist on this console. And in the wheel manager, looking at this media file name, this isn't actually the image. It's just, you see this line of text, that's a file path. That's saying when the console sees this DMX value, it's going to look through this file path, look on the local drive of this console for that image through that file path and make it appear. If I were to go onto another console that doesn't have those images imported onto it, then this file path is basically a path to nothing. There's nothing going to be at the end of that path. Will, do you have anything to add to that?
I'd say it's worth the effort to try to find it in the Carillon library.
Definitely. That's a guarantee that it's going to work on every console.
If you don't want to have to use a desk to find it, it's on PC.
Oh yeah, absolutely. So if I were to go into on PC, local disk, program data, which is a hidden folder, make sure you unhide your folders. MA Lighting Technologies, Grandma, the software version you're on, and then the Gobo folder. Here is where you can input your user Gobos.
Guys, I think we have a funny feeling that I think the screen sharing is potentially frozen. So let's see if we can click it off and back on and get it unstuck. Just stand by for a minute.
Connection lost.
All right. Sorry about that.
Those technical difficulties. So I'm going to go through that file path again. In the folder, local disk, program data, MA Lighting Technologies, Grandma, the software version that I'm on, which is 3125, and then finally Gobos. So this is that same file structure that you were looking at in the software. Same files here. There is a user Gobos folder, which you could drop in your custom user Gobos, or if you wanted to quickly look through the different images, you can look at them here on your computer. This is what I do when I have to input Gobos for Claypaky fixtures, which is a faster way to scan the library, and then you can quickly find them in here, or even search the file name of of that Gobo.
Someone's also wondering, can you reference an image from the image pool?
No, I don't think so. I don't believe so. No.
Image pool came after the structure of fixture profiles was already established, and there's a wish on the list, of course, that fixture profiles will one day very likely be able to reference the image pool, but as of 3.2, not yet.
Cool. So moving on with Gobos, this is a completed Gobo wheel, just to see what that looks like with your finished Gobo product. You'll have all your slots assigned, MX values, and your images. And then in the encoder bar, we get to see our mythos, and here's our images. Cool. So that's Gobo. It takes a little bit of time. You want to do it perfect and right, and having quick shortcuts to those Gobos. Color wheel is very much the same. Same structure. You have a color wheel manager. You can assign the color to that specific slot using the color column. Give it a name. You don't need to put in a media file name. You just need to assign a color, and then in your color wheel attribute, make sure you assign the wheel. And I'm looking at my sub-attribute here. This is the default sub-attribute for color 1 is random. I'm going to go ahead and change that to select. Now if I go in here, I can add my function sets. I can name these colors, or I can call them color 1, and then I can assign my DMX values like you do. So it's a very similar process for color wheel. Shutter is a bit of a beast, especially if you want to visualize it in 3D. I remember yesterday we talked about sub-attributes are the source for MA3D to visualize that attribute, specifically the from and to physical columns. So if we look at our fixture here, and our shutter strobe is up here, we have the light off, which is shutter at 0. And then we have a strobe effect, and then the light is on, and then a pulse effect, the light is on, and then random, and the light is on. So that's about 1, 2, 3, 4, 5, 6, 7 different sub-attributes, right? I like to use the regular shutter for the on and off. That is where the from and to physical column comes in handy. So if this is an off visualization, then we tell the from physical to be at 0. And then we can put in the range of strobing, so 1 second flash to 12 seconds flash. These are generally in hertz, but it won't show you that it's going to be a hertz value until you change the sub-attribute. So because this is a strobe effect, we'll put in strobe, and now we have hertz. Okay, this is open, this is pulse, this is open, and then we have random. Okay, and then you get to go through these different DMX values, assign them according to your ranges here. So the first one is going to be through 3, and then we have 4 through 103, and then 104 through 107, etc., etc. And then you do the same calculation here, 107 divided by 255 times 100. You get your value, your percentage value, 104 divided by 255 times 100, right? And then you get to add your function sets. So I usually do a min strobe and a max strobe.
One piece of advice here with all this number entering that we do, it's good to get yourself a 9 keypad. You know, a full-size keyboard has the 9 keypad on the right side, or I myself, since I work on laptop a lot, I just bought myself like a $10 USB 9 keypad that includes the divide symbol and the times symbol and stuff.
So you just be clicking away instead of clicking away on your mouse, like you can probably hear on my mouse. And yeah, so that's your strobe attribute. The biggest thing with strobe attribute and the most time-consuming thing is creating all these sub-attributes per functionality of that fixture, per strobe effect of that fixture. Right? Moving on down the line, I think finally we have the Prism wheel. So there's been a big debate as to what attribute, and I guess less of a debate about what sub-attribute. What attribute do we use for Prism? You could use the effect wheel, and then there's also in the beam preset type, Prisma 1. It's always fun looking. Feature request, search, select attribute. Yeah, it's in here. I promise. There we go. Prism 1. So the Carillon library likes to use effect wheel. I think we are transitioning to using the effect wheel attribute. So the Prisma attribute, it's probably going to change down the line again, such as technology does. For this example, I want to stick with effect wheel, what the Carillon library has. I think this is going to be helpful, like what Will was saying with fixture swapping and cloning and etc. This is the Carillon standard here. So if you have a prism, you're going to use the effect wheel attribute. If that if that prism rotates, you're going to use the effect index rotate attribute. That's got the little caret symbols. So looking at the effect wheel, we have effect wheel select. This will not visualize anything in 3D. The one sub-attribute, and thus causing the debate, that does visualize Prism is the Prism sub-attribute. Okay, what this does is it gives you a from and to physical, and also the additional physical. What that does is this splits the beam into this quantity of this number, in this quantity. So right now we have a 7-degree spread of 3 beams. We can make this be further apart by changing the from physical, and we can add beams by changing the additional physical. This fixture profile in particular has a prism wheel that does, I believe, 4 linear and 8 circular. This doesn't really define it, but from my knowledge, I do know that it has 2 prisms. in 3D, you can only visualize a circular prism. Linear prism is not visualizable yet. I'm sure that it'll come down the line eventually. So that means if we have an 8-facet prism, we have an additional 8 physical. And I'm going to leave this at 7-degree beam. You can change that just to finesse it. Again, you want to go through your from and to DMX values. So this first one is the open, no prism, which is 0 to 10. And then we have the 8-facet prism, which is 11 to 132. And then we have a third prism, that's 133 through 255. Assign the correct sub-attribute. And this has a 4-facet. Cool. Finally, you want to go in and create your function sets. And I didn't do the calculations for this yet, so 255 times, ooh, didn't quite get that. So what I did there is I made sure I had the sub-attribute level done with the from and to and the DMX. And then I added this, and I just go into the from and I say 0%, and it goes to the lowest natural range that it can go to, which is 4.31%. And then I go into the to column and I type in 100, and it goes to the maximum percentage that it can go to, which thus fills in the proper DMX values. Just a little quick shortcut. There you go, there's Prism. If you want to rotate Prism, you need to use the Prism rotate sub-attribute. If you index the Prism, you need to use the Prism rotate index sub-attribute. But again, rinse and repeat. Oh, it's called the position, Prism 1 position. Fill in all the info, create your function sets, and now you have a visualizing Prism that rotates in 3D. Oh man, that was a lot. That's a lot about fixture profiles.
It feels like just surface too.
Yeah. Did I miss anything? I didn't talk about Gobo rotate, but it's pretty much the same exact functionality as the Prism.
We had wanted to talk about something yesterday that we didn't get to. Spencer, when you went to pick an attribute in the list, so this select attribute list yours is pretty big. Many times people call, they go to add an attribute and it's not in the list and they don't know why. Can you just show them why it's not in the list and how you can get it into the list?
Yeah, absolutely. So this list is the compiled list that Caroline has created. If you don't see the attribute in this list, you can create your own. You are not limited to selecting just these attributes. You notice that I have like 4 dimmers, I have 3 or 4 pans. I created those in the attribute and encoder grouping button here. So if I back all the way out, that's in setup, patch and fixture schedule, fixture types, and then on the top right here, attribute and encoder grouping. Okay, this again kind of shows you those layers that we were talking about yesterday. We have our preset types, which is the first layer of our encoder bar. And then we have the features. Those live right here in our encoder bar. And then we have the attributes, which live on the final layer of the encoder bar, and the sub-attributes, which live within the fixture profiles for visualization. So let's say I want to create a beam effect attribute. So you just kind of click through the different quadrants to get to, first, obviously the preset type is going to be beam. The feature of that, I could use what's here, or I could create a new one. I'll just create a new one. I'll call, by right-clicking on that new column, and I'll call this the wheel effect. Right? And now you'll notice that my attributes don't have anything in there. So So I need to create a specific effect, which we'll call beam rotate. And then finally, we need to add a sub-attribute. Now, if you don't add a sub-attribute, you won't be able to find this attribute that we just created in your list of selectable attributes. You have to create a sub-attribute for every attribute that you create. Roted, beam roted. And now this is a selectable attribute in our list. So it's in the beam preset type, which is that far left column. Scrolling down to beam, and then it's in the, I forget which, oh right, we called it the wheel effect. And then here's our attribute that we created, the beam rotate.
This is probably one of the attribute and encoder grouping is probably one of the more confusing areas of the console. And we had a webinar last week, what stumps us. This can stump people a lot. When you go to select an attribute, what's available there is based on what's already in your attribute and encoder grouping window. So Spencer, if you jump back to attribute and encoder grouping, this compilation, the order of these attributes dictate how they're laid out on your encoders. These are part of your show file. So if you start a brand new show file, this list is fairly minimal. Notice somebody asked, what is Carillon? We keep talking about Carillon, so I thought I'd explain that a little bit. Carillon is a company based in the UK that compiles fixture DMX information. So they encourage all fixture manufacturers of the world to send them their DMX charts, and they compile it into this big, huge database and try to standardize the names a little bit. Console manufacturers around the world will lease that information from them. So MA, for example, leases that database. ETC leases that database. There's a few other console manufacturers that lease that database of information. And then we compile it into the software. There are over 1,500 unique attribute names in the Carillon database. Daunting, to say the least. And when you go to add an item, you actually see them. So when you're building a fixture profile, if you go to select the attribute and it doesn't exist in the list, Spencer showed you a way that you could do a custom one. But we always encourage you to try to use one that already exists in the Carillon list. And as you scroll down or you start typing some letters, it'll start filtering them down. And this can be kind of one of the longer processes for us. Dimmer is dimmer, pan tilt, those are all standard names. But you get these funny LED fixtures where it's like, red effect 2. Like, oh, what great. Which one should I choose? And we usually are trying to use the existing naming because we don't want to keep adding these custom names to your specific show file. These end up as custom names to your specific show file, then you never use it again, and then it's gone forever. We're discovering that through the years, people carry their show files through versions and versions and versions, and they add fixtures, they remove them, they add them, remove them. Nobody's ever going in and cleaning up their attribute and encoder grouping window. We've been getting some show files lately where we go in and look, and they're just their show file itself has over 450 attributes, but they're only using 100. And it's like, oh, you got to keep your database clean, Yeah,
that's what's happening in this show file. Is I'm compiling a lot of custom and now unused attributes, and that means that's a lot more attributes to scroll through.
Yeah,
it's not fun.
And then you end up picking the wrong ones, and then your fixture swapping and your cloning doesn't work because you don't have the right names. But I will say, we recognize that cleaning up your attribute and encoder grouping window, why would you know that? We never wrote a bulletin about it or anything. So we're discovering this recently, and we have it on our list to make a bulletin about it so that people are aware of data management. The job of the programmer, manage your data. Cool. Well, we have a few minutes left. Did you get everything covered, I think?
I think so.
That we wanted for today. Tomorrow is, the multi-instance fixtures. We had a pre-question I just want to cover real quick. I think you're in the right spot, Spencer. There was a question, how do you handle LEDs that are structured GRB instead of RGB?
Sure.
Well, easy.
I mean, let's say we have our GRB fixture. That's just a matter of you placing those attributes in that order. So instead of it being RGB or color RGB 1, 2, 3, it's going to be the other order. So I would choose green first, up here. Color RGB 2, GRB.
GRB, yeah.
GRB.
Yeah.
Boom. So you just put them in that order and then assign the course number that corresponds with your DMX channel chart, which would be green would be course number 1, red would be 2, and blue would be 3.
Yeah. And keep in mind, yesterday we showed you the course number doesn't have to be in order. Your attribute list doesn't have to be in order. You're free to either way.
Sure.
I could have RGB and I could just number it 2, 3, 1. So we've obviously had some questions about modules and instances. We're covering that one tomorrow, so join us for that very unique approach. I like this question. Any tips about media server fixture profiles?
Oh my goodness. Contact the media server company and ask if they have the profile. Yeah. There's a lot of gnarly video attributes that exist. That it's gnarly.
Sometimes when you have something that unique, getting familiar with editing XML can be handy.
Yeah.
Sometimes it's maybe easier to see and copy and paste data, and I recommend a program called Notepad++. It displays XML data real nicely. Frankly, I don't use it a lot for editing, doing a lot of XML editing, but some people have, they're really into that, just data, and it's okay. But most of the media, since the media server manufacturers, there's really some main players in the industry. They have a tendency to kind of manage their own. PRG's Mbox, Matt Cork does the fixture profiles himself, and they are in the console, but he keeps tabs on updating them, by the week. So a lot of times we just suggest people go there.
Also, a lot of media servers will already be in the internal library. Like I know Archaeos is in there. Will's saying Mbox is in Mbox. Maybe if I could spell box right. There we go. PRG is the company. Was it Green Hippo is the company. So a lot of them will be in the library already.
Yeah.
Nice.
They're all in there. It's just terminology is sometimes a little different.
Sure.
The reason the Mbox, they manage it themselves is that they wanted some specific names, and the Carolina is using different names that differ from that. And that's just between, Mbox and Carolina. They'll work it out over time. I like this question related to media servers. Are media server profiles created the same way as fixtures? Yes.
They just are fixtures.
Yeah. This is our editor. What you've seen is our editor. We have no other tools. So you have the same tool. So, all right. I know there's a couple other questions. Remember, if you're based in North America, you can email support@aclighting.com. If you're anywhere else in the world, contact your local distributor with any questions you have.
That about concludes this webinar about fixture profiles, day 2. The specifics of building particular attributes and how they visualize in 3D. I want to thank you for you guys joining us and listening to me drone on about the fun that is building fixture profiles. Go out there and start building them yourself. And feel free to email us if you want us to double check what you've done, or if you have run into questions along the way. We are always happy to help. Email us at support@actline.com. On that note, keep it classy.
Happy programming.